Today in Algebra Lesson B2, Formalizing Relationships with Functions. If you're looking in your textbook, this is Lesson 4.6 or 4-6. The standards are listed here, and here are the I can statements. So I can define a relationship function using domain and range. That's a key thing today. Determine if it represents a function. I can explain if any letter used in the function notation, such as not just F, that we're going to use G and H and some other ones. I can decode function notation and explain what a function rule means. I can evaluate a function for a given domain value, so I'll give you some options there, and identify numbers that are not in the domain of a function. I can also choose a domain that makes sense based on the problem situation. So some of our vocabulary that we are looking at, a relationship. So when we are talking about a relationship is when we look at that, it is a relationship between two variables is what we are talking about. So when we say relation, it's how two variables are related. A function is a relation where the input value has exactly one output value. So as we look at that one output, domain is the list of all possible input values. So it's what you're placing for your x value, what makes it true. And then the range is the key thing, is your output. So a lot of times we think of input. We also think of it as our x values in a function. And our output, if we're thinking about a table, it's going to be our f of x, or sometimes what we have referred to in the past, your y values. Okay, so keep that in mind as you are working with it. Now, how do we use mapping and diagramming when we are working with our functions? It says when you're given a list of ordered pairs, a good way to determine if it is a function is to use a mapping diagram. And the mapping diagram is really just these two circles where we're going to put domain and range. Step 1 lists all the numbers in the domain in one column and the range in another. If a domain is repeated, only write it once. This is key. Same thing in the range. If it's repeated, you're not going to put it down twice. So you notice here that the 2.5 occurred twice. We only put it in there once. Using the list of ordered pairs, draw an arrow that connects each x value in the domain column to the corresponding y value. If each domain has one arrow, it's a function. If it has two or more arrows touching a domain number, then it cannot be a function. So here are two examples. So as we look at mapping it, this is what we want to do. We're going to list our numbers under the word domain. So we put domain, we list -2, 0, 4, and 5. Remember, domain is really the x, okay, when we are looking at an ordered pair. So the domain is our x values. When we are filling in the range is really our y values. So these are kind of our x in our ordered pair, and the range is our y, okay? So this is how we're going to map it. This relation is a function if we are looking at it. Because, and the question often comes up, but doesn't 0 go to 2.5 and 5? Yes, but again, these are my x values, and you can have these going to 2. It says two arrows cannot be touching the, a domain. So over here, this one is not a function. Okay, so make sure you're clear on that. Now, as you take a look at the top of the next page, and as you take a look at that next page in your notes, as we are looking at that, one of the things now, it says when you're given a graph, a good way to determine if it's a function is to use what's called our vertical line test. It says if you draw a vertical line anywhere on the coordinate plane and it only passes through one point on the graph, it is then a function. If it passes through more than one point, then the domain value has more than one range and it cannot be a function. So if we look at this, and again, if we were going to list this at -4 under the domain, we have it going to both 2 and to -1. Also, so if we're looking at that, that's the one that does not meet the vertical line test. All the rest of them meet that vertical line test. It is not a function because it went through 2 points. And if you're given a reason, that can be your reason that you're looking at. As we look at this equation, y equals -x squared plus 3, and we draw a vertical line after it's graphed, it is a function because it passes the vertical line test. So, first thing we're going to be asked to do, determine if it's a function. The first ones we want you to use a drawing the map, and the second one's a vertical line test. So when we start this off, we're going to start with the word domain. We're going to put domain, and my pen is not working, domain, and then we are going to put our range. So for the domain, we're going to have 4.2, we're going to have 5, we're going to have 7, and we have 4.2 again. We're not going to write it again. When we are mapping it, we have 1.5 for our range, 2.2, look and notice I'm just simply taking the y values, 4.8, and 0. So now we want to draw our map. 4.2 goes to 1.5, 5 goes to 2.2, 7 goes to 4.8, and 4.2 goes to 0. And the question is this going to be a function? So since 4.2 in our domain goes to 2 ranges, this one is not a function, if we are looking at that. Not a function. Why? Because 4.2 has both 1.5 and 0. So it'd be like at 4.2, I would have the point 1.5, and I'd also have the point 0, and it would not pass the vertical line. Again, we want to start with our domain and our range. So try this one yourself and try and decide if it is a function or not. Pause the video so that you can actually fill those in yourself and try and decide, is it a function? And when you are done pausing the video, you'll see how I've written it and written if it is a function or not. Now again, you're going to see that I've written down the domain and range, and it is a function. And the reason it's a function is each input has one output. The reason this one is not a function, 4.2 has 2 outputs. So if I'm asking you in your homework, is it a function or not, and why? The why part is if it has more than one output. It's always a function if each input has one output. So we are now looking at this bottom part, and if we look at this one, do you think this is going to pass our vertical line tests? And we would say this one is a function, and our reason is it passes the vertical line test. So you can say it passes the vertical line test. You could also say each input has one output. So please try the next two, and right below if you would give the reason that you say it is not a function, and then as you start up the video again, you will see what I have put down for these answers as we are looking at those. So pause it, try the next two, and then go back and rewatch it or look at the answers. This one should be not a function. Our reason for it not being a function, if I'm looking at right here, does not pass vertical line tests. The other reason we could say, if you are looking at that, is that -2 has 2 outputs. If it's a function, it can only have one. This one is definitely not a function, if we are looking at this, because it has many places, and my vertical lines are not the best, but if we are drawing that vertical line, it has many places where it crosses at more than one point. So our reason doesn't pass vertical line tests. Okay? So part of your homework is going to be asking you if it's a function or not, looking at the vertical line test and looking at that homework. The other thing is our function notation. Now, before you have seen equations written like this, and you graphed them last year, slope-intercept, you looked at those. Now the only thing different is we put this f of x. And this is a notation that's used quite a bit in your advanced math classes. As you get into Algebra 2 and your advanced math and calculus, they always use the f of x. They might use w, they might use another letter, but it just replaces the y, and it is read as f of x. The letter f is the name of the function, not the variable. Function notation is emphasizing the function value depends on independent value of x. So x is still independent, y is our dependent. It says besides f, they can use other letters, g, h, and you're going to notice down here as we read this question, they use w. It says if w of x equals 250x, it represents the number of words, so they use w for words, that you can read in x minutes. How many words can you read in 8 minutes? So first thing we're going to do is we're going to look at our notation. W of x, we're going to write down our equation. But then instead of putting x, we're going to replace x with 8. So it's kind of like we did up here. We just replaced the x with 8. 250 times 8 gives us 2,000. It says if we wrote this without function notation, this would be how it looks like. So this is what you've done before. So it's just a little different, but it's not harder, just different. So what you are asked to do now is look at these different functions, and if you would please, as you are looking at those, what we want to do is we actually want to substitute in our values. So I'm going to put g, I'm going to write the equation, g of 4, and I'm going to replace that 4, and then I'm going to go up to the equation, which was right here, and I'm going to rewrite 2, but instead of x, I'm going to put 4 minus 4, and I'm going to solve that. So what is g of 4? You're going to keep the g of 4 out in front. It is 8 minus 4. So g of 4, we read that as, is equal to 4. I would like you right now to try the next 3. I'm going to pause the video. I would like you to pause the video and try them. Check with your shoulder partner, and then take a look at what I've done. As I started this next one, you can see that every place where the x was in this equation, I replace it with a 4. 4 squared, so I say h of 4 equals 16 minus 16, so h of 4 is equal to 0. So try the next 2, again pause it, and then start it up as you need. You can now see the answers for the rest. If you need to pause the video to make sure you check yours and get the right answers, please make sure you do so. And then we want to look at this last part. In this last part, we're talking about what's a reasonable domain and range. And what might happen is that the video might just run out of time and I need to start another one to add to it. But a reasonable domain and range, if you have 3 quarts of paint to paint the trim of your house, 1 quart we know is going to cover 100 square feet. And the question is, this situation we just want you to know is a function. It can be modeled by this equation, area equals 100 cubed, where Q is the input, A is our output. So find a reasonable domain and range. A reasonable domain is the set of input values that will work. Now, in this case, if we're talking about quarts of paint, can it be negative? No. Can it be 1,000? No. Could we use a fraction of a quart? Okay. So thinking about that as we are looking about it. So we cannot be 0. It could be exactly, the least domain is 0, the greatest is going to be 3. A reasonable range is a set of outputs that will work. So can it be negative? Meaning, can our area be negative? Could it be over 1,000? Well, think about when you take each of these times 3. That's our most that we are looking at. And says, can you write an answer in both a sentence and in an inequality? So I'm going to show you this, and I know you're definitely going to want to pause the video so that you can read through this. And this is what you want to write down as you are looking at it. So you definitely want to write this down, but take the time to pause the video and read through this, please. You can use at least 0 quarts. The least value is 0, and you have only 3 quarts, so you can paint up to 3 or use 3. The greatest domain must be 3. You can have fractions or decimals, so it can be any number between 0 and 3. This is how we're going to write our domain. 0, Q is greater or equal to 0 and less or equal to 3. The areas, well, if we use 0 and plug into that formula of 100, we're going to have an area of 0. And the biggest area will be, if we are looking at that, 300. I'm going to stop this video and I'll start the next one to add to it.